Many companies already moved to cloud or are in the process of moving to cloud. And one of the common complaints in relation to cloud is the cost. It's too expensive. We shouldn't have done it because it costs so much. And I do not think that's true. I mean, it does cost a lot, but only and exclusively if we waste resources or if we have unoptimized systems. If we do not waste anything and if our systems are optimized, then cloud might be more expensive than on-prem, but the difference is not that huge if we do the right thing. In one of the previous videos, the one about Cast AI, I explained how we can scale our clusters by taking into the account the cost, not only the workloads and whatever else we normally do, but the cost itself. And Cast AI is doing a great job at that. It also shows us how much things will cost, but that's not its strength. Even though we can see how much something would cost with Cast AI, that information is not really detailed. It is not sufficient. We need something better. We need something that is giving us all the information we need to establish what is worthwhile doing and what is not worthwhile doing, and how to optimize our systems to be not only more effective, but also cheaper. So when we talk about cost, and especially cost related to Kubernetes, we usually think in terms of clusters, nodes. How much does it cost to use those nodes instead of some other types of nodes or sizes of nodes? How many nodes we should have, whether they should be spot instances or no, and so on and so forth. Now that's very important. We need to continue doing that, but that's not enough. We need to take into account other services like storage, load balancers, traffic, and so on and so forth. We need to know how much something costs, and that something is not only a service like EKS cluster or GKE cluster and nodes and load balancers, but also how much does it cost to have a certain namespace, or how much a team in a company is spending, or how much does it cost to have certain environment like dev environment versus staging environment, and so on and so forth. We need to have different layers, and for each of those layers we need to know how much something costs right now, how much that something will cost in the future, and what we can do to reduce those costs or to optimize the system, or even better, both. How can we reduce the cost per team, per application, per namespace, per cluster, and make it more optimum at the same time? So we need a solution, and that solution might be Kubecost. So let's go through it. Let's see whether it is really good, whether it is something we should use. I already created a Kubernetes cluster, it is up and running, and I already installed Kubecost inside of that cluster, so we're going to jump straight into using it instead of going through the setup. And if you do want to follow along, then the link with the gist is in the description of this video, so you can reproduce what I'm doing. Even though there aren't many commands today, most of the things are very UI based. Let's start by opening Kubecost in a browser. I should have set up Ingress for that. I didn't, I was too lazy. So I'm going to execute kubectl with this namespace, and then I'm going to port forward to the deployment of Kubecost itself. And then I can open it in my browser using localhost 1990, and there we go. This is the initial screen that shows all the clusters that we have. I did not use real clusters today because, I cannot show you the real deal, but I do have a demo cluster that should be just enough to demonstrate how Kubecost works. So let's go into the only cluster that I have for you today. Now, since this is a demo cluster, you will see that the amounts are relatively low and it doesn't exist for a long time. So in your head, you need to multiply this with 10, 100,000 or 10,000 to get the real numbers of what you could benefit with Kubecost. In my case, it's a small demo cluster, so you will need to excuse my tiny numbers over there. But even in such a small cluster, and from the get-go, we can see that there are some monthly savings that were identified. We can see how much that Kubernetes cluster costs monthly, and cost efficiency, which is a percentage of how much something is or isn't efficient. And below those, we have some graphs with cost allocation and Kubernetes assets costs and cluster efficiency. We're going to see all those in details later. What matters for now is that we are presented with a dashboard of sorts where we have a quick look at what's going on a very, very high level. And at the very bottom right of the screen, there is external cloud costs not configured message. And if you click the button that says configure cloud integration, we are sent to the instructions, to the documentation that shows us how we can add certain labels to certain resources so that Kubecost has better idea about what we're using and how much that costs and so on and so forth. It is very useful even without those labels, but if you do add the labels, then you get the real deal, which I'm probably not going to have time to show today, but we'll see. Maybe I will, who knows. Now let's go back to the dashboard and see what are those monthly savings that were identified. Let's see what we'll get behind that tentative message. In the savings sections, we have a couple of groups or types of savings that we can make. The first one says right size your container requests, which is one of the most important thing about Kubernetes manifest that people usually forget, or more often than not, do not put it right, do not make it really what it should be. So let's see what we'll get over there. Now, if you take a look at the summary, we can see that CPU is disastrous. It's horrible. All the applications that I have in my cluster requested 1.14 CPU and only 16 CPU milliseconds were used. If you're not sure what CPU millisecond is, well, 1000 CPU milliseconds is 1 CPU. So this is way below what I requested. I requested much more than what I'm using, and Kubernetes needs to fulfill my requests. So my nodes must be very underutilized, at least from the CPU perspective. RAM is much better in my case, but not much better really. Around 60, I think, percent of memory that is requested is really used. So almost half of it is wasted. More important part is actually the breakdown. You know, the summary is summary. You cannot do much with the summary, but breakdown is very useful. We can see that some pods are under provisioned, meaning that they requested less than what they really need. But in this case, in case of this cluster, that's more of an exception than the rule. The one I'm really interested in is the application that I deployed called DevOps Toolkit. So let me scroll down and find it. There we go. It says production/DevOps Toolkit. So right now, at this very moment, CPU is not used by that application at all. Now, we shouldn't assume that it will never use CPU, but right now the usage is so low that it says 0 CPU milliseconds is used. But that's very different from what I requested. I requested half a CPU or 500 CPU milliseconds, and that's way over what I obviously need. Kubecost actually recommends that I use 10 CPU milliseconds instead of 500 milliseconds. So I should request 50 times less CPU than what I did. Similarly, that application is using 3.5 megabytes of RAM. I requested 512. That's way over what I'm currently using. So the recommendation by Kubecost is to change those 512 requested megabytes of memory to be 20 megabytes of RAM. That's way lower than what I'm currently asking for. So let's take a look at the pods that I'm currently running, the pods of that application running in the production namespace. So the command is kubectl namespace production get pods, and there we go. I have 20 pods of that application. The deployment that defines that application has replicas set to 20. And to make things complicated, many of them, like half of them or even more, are in the pending state. There is not enough capacity to run all the replicas of my application. That's why they're pending, and unfortunately I didn't set cluster autoscaler. If I did, then the cluster would scale, but that's not the point because I do not need this cluster to scale. There isn't enough capacity to run all those pods, but that's not because the cluster is too small, but because I requested too much memory in CPU. I told Kubernetes that I need much more than what I really need. So what I should do is accept Kubecost recommendation and change the requested memory and CPU to whichever values Kubecost suggested. Doesn't have to be exactly there, but more or less I should use those suggestions. And then we'll see what we'll get. I will discover whether I do need indeed to scale the cluster, or actually I made the mistake of how much I requested, and changing the requested memory and CPU will fix the problem. So let me edit the deployment YAML. I'm using Vim today. You can use any editor, and I'm going to change a couple of things. So I will modify the requested CPU and set it to 10 milliseconds, 10 CPU milliseconds, and I will set memory to 20 megabytes. And since limits were way off as well, I will decrease the limits. They should be still much higher than what I request, but lower than what I currently have. So I will set CPU to 50 CPU milliseconds and memory to 100 megabytes of RAM. And then the only thing left is to apply those changes. kubectl --namespace production, apply, and then customize in the path to, I'm using customize by the way. If you're not familiar with customize, there's the video, check it out. Anyways, let me click the enter button and apply that new manifest, modify manifest, and then we'll see what we'll get. Now let's go back to savings and see what else we can do. And while we are exploring other savings, we are going to give Kubernetes sufficient time to process whatever we changed in that manifest, and Kubecost also to reload the data. So let's see what else do we have. We have managed underutilized nodes, and we can already save a significant amount of money over there. So let's see what we'll get if we click that link. Now look at that one. A moment ago, I did not have enough capacity for all my workloads, for all my pods. And now that I changed the requested memory and CPU, I have 2 nodes that could be shut down. A few minutes ago, I was thinking that I need more nodes. And now I'm finding out that with right sizing of my application, of my pods, I actually do not need 2 out of 3 nodes. I could shut them down, or even better, I could let cluster autoscaler scale down my cluster, which does not really always work, but that would be a separate subject, and you should really watch Cast AI video about rebalancing the nodes and so on and so forth. What else do we have? Yes, we can right size cluster nodes as well. Maybe the size of the nodes themselves are not correct. Maybe we should need bigger nodes or smaller nodes or faster nodes or slower nodes, whatever. Let's see what we'll get from this report. Now there are 2 recommendations to use nano nodes or micro nodes. I would never apply this recommendation because running nano or micro nodes is disaster. They're just too small for anything to run in. But this is a tiny cluster, so the recommendations are not really good. If my cluster would be a real cluster, then those recommendations over here should be taken seriously. Now we should probably talk about cluster autoscaler. Cluster autoscaler should be aware of those things, and we should take this recommendation and instruct somehow autoscaler to do the right thing, maybe by using Carpenter or Cast AI, which I already mentioned a couple of times. Now those things do not matter within this context. It's up to you to figure out how you want to scale your cluster. What does matter is that you have here a clear recommendation which types of nodes would work better for your workload. What else do we have in savings? We can remedy abandoned workloads. We can reserve specific instances to save some money. We can manage unclaimed volumes. You know, that's a constant headache, unclaimed volumes. Anyways, if you do have some, we would see the recommendation here to remove them, and we can delete unassigned resources. I do not have problem with any of those things. Again, this is a small cluster, but in a real world situation, I would have those problems as well, and then this would be very useful. Now I mentioned at the very beginning that cost is not only about how much my cluster costs. We need to have more granularity and visibility into the cost. We need to be able to figure out how much a cluster costs, that's obvious, but also how much we spend for each namespace or how much each team spends and so on and so forth. We should be able to deduce how much different entities, which could be human or machine entities, are spending, and then we can make intelligent decisions what to do next. And we can get that type of information from the assets section of the dashboard. So let's go there and see what we'll get. Now there is only one Kubernetes, that's the only asset we have. Now we have only Kubernetes over there, we have only one asset, the top level asset. So let me go inside that Kubernetes cluster and see what we'll get there. And this is already starting to break down. We can see that within that cluster, we are spending certain amount of money on nodes, another amount of money on cluster management, which is control plane. Then something goes to the load balancer. And finally, we have disk, how much we're spending on disks attached to this cluster. Now there's more to assets than that. We can get more granularity or different ways to filter assets. But for now, I want to move to the next subject and see the health. Let's see the health of my system. And as you can see, my system is very, very healthy. It is not 100% healthy. It is mostly healthy, 97% healthy. And we can see here all the different criteria used to deduce the health of the system. I will not go through all of those now. I do not care about those that are working well. What I do care is about those that are failing. So let me disable show all and see only the problematic ones. And there we go. One of my applications, the one that I just modified, is having CPU throttling. What that really means is that the requested amount of CPU is below of what the application needs. So the system is throttling CPU usage. I should probably tweak it a bit, increase the requested CPU slightly, a bit more than what I put over there. Now that poses a question. Does that mean that Kubecost suggested that I put certain value that is below what I should do? And indeed, that's what Kubecost did. But that was actually a mistake on my part. I ran Kubecost for only 5 minutes or something like that with an application that was installed just a few minutes before that. I should have let Kubecost run for a bit longer to get more historical data, more information about my applications before applying the requests. Nevertheless, I can see in the health section what is working well and what isn't working well, and then I can use that information to improve my system. Now there are also reports. We can generate reports and send them to somebody to read them, or we can generate alerts. We can be alerted when there is something that shouldn't be there, or something is misconfigured, or something is passing certain threshold, and so on and so forth. I will not go into details of reports and alerts. You can explore them yourself. What matters is that you can create both. You can generate reports and you can send them to yourself, and you can alert yourself when certain thresholds are reached. And those thresholds are mostly about the costs and the health of the system. Now back to cost allocation, report in cost allocation, and we can see how much we're spending for each namespace. How much does it cost to run production, and how much does it cost to run Kubecost itself, and so on and so forth. And this is very useful because we can see now more granular information of what's going on, because the cluster itself might be very expensive or very cheap, but what is the culprit if it is expensive? We do not really know unless we start splitting costs by different criteria, and one of that criteria could be a namespace. So if we click on, let's say, production namespace, we can get even more detail what's going on within that namespace. We can see the difference between requested and allocated resources and how much each of them cost, and so on and so forth. So far we saw that we can see the cost per cluster and per namespace, but there's much more to it. We can divide it by containers or controllers or controller kinds, daemon sets, departments, deployments, environments, jobs, nodes, owners, pods, products, services, stateful sets, themes, and labels. Those are quite a few different ways how we can filter the information, filter the data, and get what we need and figure out who is doing what and how and when and how much that hurt us. And by hurting, I mean in dollars or euros or whatever your currency is. Now there is one more thing missing, the last thing missing, at least from Kubecost perspective, and that's integrations. As you already saw, Kubecost works fairly well, really well, out of the box, without me doing anything. I just need to tell it where the cluster is, and it figures out that it's AWS or GCP or Azure, and it gets all the information it needs. But it can do better through integrations. And the key to integration are tags. Actually, it depends from the provider, but they're more or less going all in the same direction. If we tag our resources, whatever those resources are, then Kubecost will do a better job, will be able to figure out better how much something is and what are the relations between things. So I strongly recommend to explore integrations. You shouldn't probably start with integrations, play with Kubecost for an hour or two first, but once you get comfortable with it, and it's very easy, so there's not much to get comfortable with, it just works from the get-go. Once you finish playing with it, explore the integrations, label your resources, and then it will show its full potential. And finally, I promise, this is the last thing that I will say about Kubecost before we go to pros and cons. When we reach certain resources, like in this case pods, we can click on the link and the link takes us out of Kubecost into Grafana, because Kubecost has Grafana in the background and it has also Prometheus where it collects data and so on and so forth. So we can go to Grafana if we want to see more than what Kubecost UI is giving us. Now I will let you explore Grafana dashboards yourself. There are quite a few of them over there. They're showing you similar information as what you can already see in Kubecost, but that information is greatly extended, and more importantly, you can extend it yourself. You can create your own dashboard or edit the dashboards that are already there. So that integration with Prometheus and Grafana is absolutely awesome. I love that Kubecost is open source, and I like even more when open source projects integrate with other open source projects, so we have a whole ecosystem and nobody is reinventing the wheel, and that's absolutely awesome. Okay, now let's talk about pros and cons. Should you use Kubecost, and what's good about it and what's bad about it? So let's go and talk about pros and cons. When cost is concerned, especially when cost is concerned in relation to Kubernetes, Kubecost is probably the main candidate for your love. It is open source, I love that. It is free. It has a quite vibrant community, adopted by many. I think it's in CNCF, if I'm not mistaken, and so on and so forth. It's probably the best choice when Kubernetes is concerned, at least within free options. Now, it is not without its own problems or missed opportunities, depends how you define it. So let's go through cons first. To begin with, I think that Kubecost could tell us not only what to do, but also how to do it. It should include snippets that we could copy and paste into our manifests, or even better, it should integrate with infrastructure as code tools and then give us real recommendations what to change and how to change it. And it would be even better if it would integrate with Git, so that it can tell us not only what to do, but maybe even create pull requests with suggested changes. So what I'm really trying to say is this is not actually a bad thing. I like that it is giving us recommendation, but what I do not like, or what I think would be better, is if Kubecost would give us not only recommendations what to do, but show us also how to do it. That's a bit complicated because it would need to integrate with all the major tools like Pulumi and Terraform and Crossplane and a few other tools. And it would be great if it would be creating pull requests, but that's also a bit complicated. So I'm not really complaining here. I'm just trying to find something I do not like. And this is not something I do not like. This is actually missed opportunity. So I hope really that Kubecost will go in the future towards integration with other tools beyond those that it is already integrated with, which is Prometheus and Grafana and probably a few others. So I do not have a real negative thing about it except missing opportunities. And there are quite a few great things about it. To begin with, it is open source, it is free, we all love open source. I suspect that there will be a paid version sometime in the future, probably some kind of SaaS. I do not have inside information, so I might be wrong. Anyways, Kubecost itself is open source. You can run it yourself, and that's great. And that brings me to the second very positive thing, and that's that it is self-managed. Now, I personally love SaaS. I like not to manage things myself. I prefer using GKE or EKS or AKS instead of creating my own cluster myself. I prefer using databases as a service and so on and so forth. So I really like SaaS solutions But what I don't like with SaaS solutions is when they're only and exclusively SaaS solutions, because very often that's missing the point that many companies cannot really freely give data and access to their infrastructure and so on and so forth. So self-managed is a bonus in my book, even though it would be great if there would be SaaS version as well. But if I would have to choose between the two, self-managed goes first because that covers more use cases. Now, next positive thing might sound confusing because it is somehow contradictory to what I already said in the past as a negative thing, and that's that there is no runtime remediation. Now, you would probably expect, hey, I would like a button that I click and then this is fixed. Then my cluster scaled up or scaled down, or requests and limits were changed in my pods, in my applications, and so on and so forth. People like that button, but I believe that it's a good thing that there is no such a button, because that invites bad practices. As I mentioned before, I would love if Kubecost would integrate with the tools that I might be using for infrastructure and for services. I would love if it would create pull requests, but if it's not doing those things, I prefer it not to fix the situation with an easy button that modifies something at runtime, and to give me only the recommendations. So no runtime remediation is a negative thing for some people, but it is a positive thing in my book. And finally, most importantly, it gives me almost all information that I might need to make decisions what to do in relation to cost reduction and optimization of my cluster. Okay, actually, maybe not all the information I need to optimize my cluster, but some of the information that I would need to optimize my cluster, my workloads and what's not, and almost all information I need to reduce costs. And that's absolutely awesome. It's simple, it's free, there is no good reason why somebody wouldn't use Kubecost. So try it out and let me know what you think.